just going to kind of estimate the center. It doesn't have to be perfect. Same kind of format. We're going to put vertex form on the side, on this right side at the top. We're going to convert it to conic standard form later. All right. So since this is a sideways parabola, it doesn't start with a letter y, it starts with a letter x, right? X equals. And it's going to have a negative a value, right? A negative 1/16, right? Your fraction is negative. And since x is by itself over there, that means what is being squared is your y minus k. And what we're going to write is we're going to write y plus 2 inside the parentheses. So if that's y minus k, k is opposite, then your h value is tagged at the end, and our h value is just going to be a positive 6. So I'm going to totally review this form with you a whole bunch. Don't feel like you have to have this memorized right now. But what you do need to remember is everything that we already know about vertex form is the same. Your y is always with k, but it's inside parentheses, so it's going to be opposite. So our k value is going to be a negative 2. Also, your h value is not in parentheses. So if it's a plus 6, it's going to stay as a positive 6. So we're going to plot the vertex at positive 6, negative 2. So 6 places to the right and 2 units down. And then we're still going to use this pattern right here. But again, everything's flip-flopped. So let me erase this. So we're going to take y values this time, y'all. So it's going to have a y value, an up and down movement from the vertex. We're going to square that vertex and multiply it by the a value, and that's going to give us sideways movement. Speaking of the a value, what is the a value in this problem? Yeah, that's a big stretch. This is going to be a very wide parabola. But we still need lattice points. We still need points that are just on the grids. 4 is going to work. Let's do that. Absolutely. So we're going to go 4 places up and 4 places down from the vertex. 4 squared is 16. We're going to multiply it by that stretch. And that tells me that I'm going to go 1 place to the left. Good job. 4 is certainly 1. We need another one though. What else can we use? What else will give us just a plain whole number answer? What was that? 8 is correct. We're going to use 8. Let's go ahead and just find the math on that, and then we'll plot everything at the same time. We're going to go 8 up and down from the vertex. When you square that, that is 64. Do y'all know 64 times 1/16? Yep. So we're going to go 4 to the left. Okay, let's go ahead and plot that. So there's my first 2 dots. Those are really far apart, but that makes sense because we have a giant stretch. 8 up and down, and then 4 to the left. Okay, you guys can kind of see that curve. Sketch the best you can. It's a pretty wide parabola here. Whatever's being squared, so you're going to isolate y to put it in conic standard form. Okay, so let's see how much you retain from what we did on the front of this page. Remember the focal width. What is the focal width of this parabola? 16 is correct. Very good. Find where the parabola is 16 units across. Where the x equals 2. That is correct. So this is your focal width right here. So I'm going to draw a dotted line. And this distance is 16 units. And I could count 8 spaces from the edge to find the midpoint, but I know the midpoint is always in line with what? The vertex. That is correct. So if that's my vertex, then here is my midpoint, which is called the focus. Now remember, focal width is 4 times p. Our focal width is what measurement again? What is the measurement that you just counted? 16. So what's the p-value? Yes, it is. That is correct. Mathematically, 14 or 4 times 4 is 16. How can we prove that on the graph? How can you prove that? Mathematically, we did it in our head. Yeah. Look at where your focus is. You can just count those units and you're going to get 4 anyway. So this is 1, 2, 3, 4 places away from the vertex. What's 4 places away on the outside? That thing. Do y'all remember what that line is called?
Directrix.
Directrix. We're going to write that down, I promise you. It's like direct. You know how you spell direct? And then RIX. It has an X at the end. Yeah, directrix. Directrix ends with the letter X. You'll see. We're going to write all that vocab down, I promise. So what is our best friend in conics? It's this measurement right here. P. P. But this isn't P. How many P's is this? Almost. Sorry, P. All right. So what we're about to do is we're about to go into the packet, page 11, like in the middle of the packet. There are so many blanks there, like it could be confusing. I bet you are going to get all of these blanks right on the first time. So let's go to our packet. Let's find this. This is page 11. Let me get this cart out of the way so I don't fall and embarrass myself in front of all these kids. And let's officially define everything we talked about. Okay, here we go. Any questions on where that's at? Page 11. Are we all here? We ready to go? Okay, then let's do it. Definition of a parabola. A parabola is a set of all points equidistant from a blank and a blank not on the line. Here's what this stands for, y'all. A parabola is the set of all points on a plane, in a plane equidistant from a line, called that weird word directrix. And a point, which is called the focus, not on the line. So let me go back for just a moment. If you notice right here, this is what that means, equidistant. Don't write this on your paper. This is a lot of busy stuff. But here's the focus. Here's the directrix. Every single point on the parabola, let me change color. Here's the parabola. The distance from the focus and the distance from that line are congruent. That's the definition of a parabola. Way up here, this point, way far away from the vertex, if I drew the distance to the focus and drew the distance to the directrix, those measurements are identical. They're equidistant. That's what this is meaning by this vocab that we're filling in here. So let's go ahead and take a look at the next sentence. Any point on the parabola is the same distance from the focus as it is from the what? Directrix. Good job. That's what makes a parabola, that sentence right there. Okay, P, our best friend in this section. P is the distance from the vertex to the what? The focus. Great job. And from the vertex to the all right, and then A. Remember, the reciprocal of A was the official focal width. So, and how many P's were in the focal width? So if the reciprocal from A is 4P, then A is the reciprocal of that. A is 1 over 4P. And just remember 4P is the reciprocal of A. And why do we like 4P? Because that's the official focal width. Should we write out what focal width is? Or are y'all gonna remember that? We'll just write it out because I already started writing it out. Okay, so here's the deal. Not yet, I'm saving that. The blank and blank are perpendicular to each other. What was that? Do you remember? Yes. Y'all, let's just write AOS for axis of symmetry. And the directrix are perpendicular. Okay, and then I call it the focal width because I don't like what the real term is called. And I'm going to write the real term of the focal width, and there's not going to be any giggling, right? I'm just playing with you. It is called the latus rectum. And we don't really like to say those words because I guess I'm kind of got a junior high mind too. So the latus rectum, or the LR, is the line segment with the endpoints on the parabola through the focus of the parabola and is perpendicular to the axis of symmetry. So all kidding and playing around aside, truly, you guys need to know the word latus rectum. You also need to know the word focal width, because I have no idea how it would be printed on like a college entrance exam. And they both mean the same exact thing. You just have to memorize both terminologies. And remember, those weird words, focal width, latus rectum, that is 4P. All right, so I think you have some space. We're almost done. We're going to finish here in just about 2 minutes. The last thing that I would like you to write, and you're going to write this a lot, but I just want to show it to you before you guys leave for the 3-day weekend, is conic standard form. And remember, you now know there's 2 ways to graph a parabola, up and down, vertical, or sideways. Let's put the vertical on this side of the paper. And the vertical is just x minus h, close it, square it, equals 4p times y plus k. And your horizontal is just, everything's just flipped. Let's put horizontal over here on this side. What do you think horizontal starts with? I couldn't hear you, but I feel like it was this. I hope it was y minus k, close it, square it, equals, it's still 4p. X plus h, yes. That's it for today. We're going to do, oh, so much more with that later. Any questions? Okay, that's it. And you guys remember focal width? How many p's make up focal width? 4. How many p's is the distance from the vertex to the focus? 1. What about from the vertex to the directrix? 1p. Okay, then, what is the distance from the focus to the directrix? 2p. You're going to have to know that one too. KVA, do you guys have any questions? Where do I look? I look over here. Any questions, KVA? Okay, then that's it. They're zipping up. They're getting ready to leave, so you guys can go ahead and get ready to leave too.
Have a good weekend.
Thank you, you too. Bye-bye.